Well, welcome everyone. My name is Zach Wyatt with Cambridge Technology, and welcome to the webinar Beyond Prediction Using AI Machine Learning for Data-Driven Utility Operations. We're co-hosted today by Amazon Web Services. Just to introduce our presenter is Rajan Lukos. He's our data scientist and CTO. He is based out of Oakland, California. And again, my name is Zach Wyatt, Director of Sales, and I'm based out of Charlotte, North Carolina. Go ahead to that next slide, Rajan. Yep. And just a little background around Cambridge Technology. We're a 20-year-old firm helping companies create, modify, and implement their IT strategies. We're a publicly listed entity out of the Mumbai Stock Exchange with over 500 employees based in North America, Europe, and Asia. We have US offices in Atlanta, Boston, Kansas, and Louisville, Kentucky. We are a CMMI Level 5 certified company, which is a methodology used to develop and refine an organization's software development processes. And for our software development practices, we hold ISO 27001 and ISO 2000 certifications for information security management practices for our delivery and managed services. A few of our different niches are application development, BI, data warehousing and big data, machine learning, IoT, and AI, cloud strategy, migration and management, and infrastructure management services. Go to that next slide, Rajan. Go ahead and go to the next one, sorry. Cambridge Technology is a cloud agnostic provider, and we work with the major cloud providers, including Google Cloud, Oracle, Azure, and AWS. Next slide. And as you can see, we are software agnostic. Our priority is finding the best solution. So we do want to highlight Confluent for Apache Kafka streaming platforms on cloud, Tableau for data visualization, and New Relic for web analytics and monitoring. Next week, we're having 2 webinars, both focused on each focused on Amazon Redshift and Apache Kafka. And with that, Rajan, we'll let you take it away.
Thanks, Zach. Good afternoon, everyone. So I think, the talk today is really designed to, AI and machine learning is really, all over the place, and it's being applied in many different industry verticals. And we've been doing a fair amount of work with utility companies, and we wanted to make this webinar sort of give us a chance to share some of the use cases that we've seen out in various types of utility companies, just at a high level, but also dig into some details to give you a sense of what kinds of things are really becoming capable with the kind of sweet spot that we've hit with cloud computing, elastic pay-as-you-go business models, and really the commoditization of AI and data. So I'll begin with just a little bit of the general state of AI and machine learning today, talking a little bit about the hype cycle, and then really the meat of the presentation will be about going through a bunch of use cases that are relevant for utility companies. And I think hopefully that'll be just sort of interest and get the juices flowing. And then we'll sort of begin to wrap up the presentation by talking about some of the challenges that many companies, including us, as we do internal AI and machine learning applications, for your business and how to overcome some of those challenges. Talk about our recommendations for how to get started using AI solutions for your business problems. May also go towards the end, as I said to begin here, that there's lots of different industries that can benefit, and I think it is useful to look at to talk briefly about some of the things that we've done in other industries, which will really give you a sense of maybe some other things that we haven't thought about that might apply to your business. I'll be brief with that, and then finally talk a little bit about the data considerations in determining your AI path. So the hype cycle around AI, I like this chart actually, because if what it is, it says the largest companies by market capitalization, since in a pretty short interval of time, in almost 10 years, the largest companies in the world went from being Exxon and GE to being well, two of the largest are Alphabet, Google, and Facebook. So two obviously very resource and infrastructure physical companies being replaced by companies that are basically advertising companies that deal purely in information. These oil barons being replaced by the whiz kids of Silicon Valley, as they say. So this, it's easy to get sort of cynical about the hype, but when you look at really, this is an incredible transformation that's happened in 10 years. And I think that this is one way for me, I think, to always keep in mind that we're talking about something very, very serious happening. We're talking about $1.4 trillion in market value. So I just like to, put it in dollar terms to kind of set the context. Um, as far as, so companies, I think, so there's obviously the behemoths at the top, and then there's every company all through the size stack from mid caps to small caps or whatever. And there's broad uses of AI in almost any business with data. Artificial intelligence, is becoming a fundamental building block for operations. It provides real gains for improved processes and increased efficiency. And also, I think this is one area I'm particularly interested in actually accelerating innovation. And I think that's where you can really start to get some escape velocity if you've developed a good practice and fundamentals in terms of applying AI to your data and connecting it to your business problems. It's a perfect storm. So there's advances in machine learning technology. There's definitely been algorithmic advances that, and you have high performance compute options that can be pay as you go. So there's no fixed cost, and there's an abundance of data now, right? That can be stored cheaply. And it creates a perfect storm for AI to transform organizations really of all sizes. Just some survey numbers, 40% of digital transformation initiatives will be supported by AI in 2019, and 42% of executives say they'll, drive innovation in their organization. Excuse me. So now I'd like to talk about some of these use cases, and I've kind of broken them down into three areas. So we think of these use cases as falling roughly into the following categories. We'll talk about an example or two or three in each of these categories. I'm pretty high level here. Just the first group is just using AI and machine learning. I think this would be sort of the lowest hanging kinds of fruit to unlock the existing utility enterprise data when that data is organized and structured in appropriate ways. So doing more with data that already exists, basically. The second category is working with new kinds of sensor technologies and IoT devices to really generate new valuable data in the enterprise, new data sources, and then by making strategic modifications of the utility infrastructure, and then using that data with AI and machine learning to drive business value. And finally, the third category, it's actually, I think, one of the more interesting categories, is bringing completely new and novel data sources from outside of the industry into the utility industry to drive some novel applications and value drivers. And really, in some cases, we'll talk about, allow utility companies to solve old problems that they've solved in very traditional ways in some very, very new ways. So there's a lot of words on the slide, but I'll talk through it. So, I think this is probably one of the most straightforward, I think, applications, predictive maintenance, really on transmission and distribution, really any utility infrastructure assets using existing historical data. So, transmission distribution operators in electricity, natural gas, water industries, they all have a large amount of data maintenance work that's actually matched to those infrastructure assets in one way or the other. I mean, in our experience, that matching is very historical and problematic. You have to do a lot of data cleaning work, but it's there. And the idea is to use predictive AI and machine learning algorithms to exploit that data to do things like prioritize and organize schedules, just deploy human resources for maintenance and so on. So now historically, this kind of work has been done very reactively, according to heuristics that are shaped by many factors, including just historical ones. Utility companies are typically very, old companies. They've been around a long time. And they operate in complex regulatory frameworks, which shapes a lot of their business processes and how they do things. And there are, of course, lots of cultural factors, of course, when you have industries that have been around for a while. And so the result is sort of you get an ad hoc process where longevity and stability is important for utility companies, can mask some rather dramatic inefficiencies. And here I might like to say that, one of the things that I find most interesting about working in AI and machine learning in sort of specific businesses and industries is that, these businesses and industries work pretty well, right? I mean, they're successful because humans are pretty good at solving these kinds of problems. They have been historically, and I think what we find is though that when you apply AI and machine learning to these kinds of problems, it's not that it's you know, 2 or 3 or 4 times better. It's sometimes it's maybe, you know, 25 to 50% better, but 25 to 50% better is a lot, and that can make dramatic differences in people's businesses. Humans, I think we find, simply cannot hold all of the information in their head and make optimal decisions. But you know, computers can make pretty good decisions when there's a lot of complex information. Humans use effective heuristics, but those heuristics can be improved. Instead of being instead of being reactive, we want to be dynamic, proactive, and operate with real-time flexibility. So the process is, you know, at a high level is basically, you know, you collect the data that's organized historically, and you deploy these algorithms to do something like, let's say, predict the probability that a particular asset or kind of asset or asset in a certain location will fail or degrade to a certain level within a specified time. Interestingly enough, the algorithmic approaches to solve these problems actually closely resemble the methodologies used in the financial industry to predict credit risk based on the history and characteristics of a borrower, for example. It's the same kinds of algorithms, just different data. And then the next step, of course, is to use the predictions to plan preventive maintenance on the assets that need them the most. And here I'll highlight, you know, one of the things that maybe you're beginning to hear more and more about in machine learning problems is the degree to which they're a black box. So that is, you know, okay, fine. This asset has a higher risk of failing in the next week than, you know, we've ever seen before, and it's a very significant. It's moving in the top decile of risk. Okay, so that's a piece of information, and you definitely would rather know that than not know that. But what do you do with that kind of information? If it's just a black box and you don't know why that risk is changing. So you hear a lot these days about bias in machine learning and why decisions are made. And so we've done a fair amount of work in that area, and you know, trying and really seeing the value of having machine learning models that are explainable and interpretable, so that you can say, well, you know, the main cause here, at least maybe you can't really identify cause, but it's likely that it may have something to do with, let's say, the number of electric pump failures in the last month, rather than the fact that it's just that old. You know, something more specific, something that's more interpretable, something where you can take the risk and turn it around and turn it into a solution. So these predictive approaches can lead to significant savings. You know, some operators have been able to see their costs reduced by 10% in medium voltage distribution grids. Just some research that was done for high and medium voltage overhead lines and underground cables. Cost reductions of 15% have been observed. 20% reductions seen in high and medium voltage substations. I mean, these are just electrical examples. And these kinds of cost reductions have been achieved with actually improved asset reliability. So it's not, you know, typically, you know, when you're trying to cut costs, you may cut some of the quality. But actually, one of the interesting things about predictive maintenance is that you're actually getting better information about your infrastructure, so you can actually be more reliable while cutting cost, which is, you know, obviously a nice thing to have. So this is just sort of a general overview of predictive maintenance and how it kind of works in utilities. And you know, maybe we'll talk a little bit about just now about a project that we're working on with one of the largest UK water utility companies, and they have a problem where they've gotten large regulatory fines from basically having pollution events in their infrastructure, basically, you know, sewage in water that shouldn't have sewage in it, and they get large fines. And they have a lot of this kind of data that I mentioned at the beginning of the slide, data on, you know, what kind of jobs were done at what time, what's the classification of those jobs. You know, and there's all the different parts of the water infrastructure, the treatment part, the distribution part, and all of that. And so we've been working with them on all of this data, which, you know, comes from different parts of the company, and so it's not all normalized. And it, you know, a label in one that comes from one part of the infrastructure and basically one part of the company doesn't necessarily match up with the label of that same data in another part. And so there's a lot of data work that gets done. And that's, I think, very typical of machine learning and data science projects. And we've done a lot of work with them, and we've, you know, really developed some pretty good pollution event prediction models. And as I mentioned, they're, we try to make them very interpretable so that they can say, well, the risk has gone up, but why? Maybe we can think about, what to do about it and what might be causing it. Because I'm emphasizing might be causing it because machine learning models don't necessarily drive causality. They're often about correlations, but that's still informative. So maybe another example here where we're starting to look at the second class of examples where there's new kinds of devices and infrastructure that's out there in the utility industry and even in consumer homes. So obviously, you have you get many people, probably maybe many people on this call have these smart thermostats, such as from Nest, et cetera, from consumer technology companies. They're also supplied and distributed through utility companies themselves. Interesting to think why they would do that. And then partially it's because, the intelligent AI and machine learning algorithms can develop predictive scheduling, can lead to significant cost savings, sometimes in the range of hundreds of dollars for consumers. You can see, what this kind of intelligence is worth, what this kind of pure information is worth to utility companies when you look at the subsidies that they will give to users to use these devices. They're quite large, actually. And in the B2B space, I'll mention a little bit here. We worked extensively with a company that is in the business of basically managing. So you might have, let's say, a retail operation that has units all over the place, all over the country, from Florida to Alaska. Maybe, I mean, for the sake of argument, I don't want to reveal information, but for the sake of argument, let's say it's a Starbucks. And Starbucks has these retail stores all over the place, and these stores may have their own HVAC systems. And this company uses IoT technologies, which we built with them to which upload real-time data streams about the behavior of the HVAC system, the temperature in the store. And you can imagine that the scheduling for the HVAC system in Florida is different than Alaska, right? You have to have custom schedules for when the heat turns on, when the heat turns off, in order to maintain a comfort for customers, because it's actually been known and measured that comfortable customers lead to increased revenues. And you also want to be able to do predictive maintenance. You want to know when the HVAC system is perhaps showing signs of failure and be able to do something about that proactively. And so predictive maintenance and efficient heating and cooling schedules, lead to a lot of operational efficiencies that improve the bottom line directly. And so I just thought that was one example of work that we were, doing that might be of interest. I think another interesting area is just to think broadly more about data is, and this is almost, an example that I've actually have personal experience with is, obviously sustainability in the utility infrastructure is pretty important. And the ways, but working with data really allows some new kinds of things to happen. Better individual household level data, it allows kind of novel business models. For example, in California, OhmConnect is a company that what you do is they allow a business model where you have to essentially permission your electricity data to be shared by them, and that's done over a web-based process. And they are then able to monitor a household's utility consumption and send alerts for when they should try to reduce their consumption during certain times. And if they do that, they're actually paid money. And some of these incentives can be significant. And I think it's just an interesting example of the ways in which slinging around data in new ways sort of opens up lots of different new business models. Another example where new devices, this is the second class again, new devices operating on existing infrastructure can create new data that is really valuable. So medium voltage overhead transmission lines, they run for hundreds of miles in remote areas between cities, right? And how do you monitor these things? It's really expensive to manually inspect these lines for damage, and they've caused very large wildfires. It's a severe risk in California, becoming ever more of a risk because of climate change. So a source of damage could be like a tree branch hitting a line, or maybe a flaw in the insulator. These kinds of damage, they're indicated by what are called partial discharges, which is just an electrical discharge but it's one that doesn't bridge the electrodes between the insulation system completely. These partial discharge, they slowly damage a line. If it's left unmitigated, they'll eventually lead to a power outage or start a fire. So people developed special meters to gather more data about the behavior of the signals, and this is high frequency data. So it's a lot of data, and it's not entirely obvious just looking at the data, because the data is also itself inherently noisy. How to, what are the time course signatures over all of this data that actually indicate a problem? And so people have used AI and machine learning time series techniques to detect these patterns, these outliers. And it's just an example of how better sensor instrumentation kind of generates new data out of the infrastructure that with the right algorithms can drive cost improvements, give better regulatory risk compliance, and just overall safety and efficiency. The graph on the right is an actual example from real data. So the third class of things that we were talking about was really about bringing in novel data sources from outside of the industry to help old problems, to help solve old problems in new ways. Utility companies have started to use satellite images, visual as well as multispectral, and various kinds of imaging like visual and LiDAR drone images to do some very interesting things. These data sets, they're only now possible for companies to effectively deal with because of the economic inefficiency of elastic cloud storage and compute. That's sort of the sweet spot argument. The time is now to really, it's only been possible now to do these things cost effectively and at scale. They can add tremendous value for utilities, as I said, in many cases solving old problems in radically new ways, and sometimes allowing solutions where none have really ever been possible in the past. And so we'll talk about a few of those right now. One example is water leaks. So you have water infrastructure, and water leaks happen all the time, especially in old water infrastructures. Sometimes in urban areas, sometimes in remote areas, it's hard to even find these things. So traditional leak detection approaches were things like, well, just manual reports, or I think that there's some old, there's longstanding approaches where people are using manual acoustic signatures, I guess, where they're actually in effect listening for water leaks. But satellite technology enables radically more efficient solutions to this old problem. So satellite imagery, it's sort of a revolution in that's been happening over the past few years. It's available from many companies at an ever-increasing cost. I think it costs about maybe less than $50,000 today to really launch your own satellite into orbit, something that can send back images, on, let's say, a daily basis, maybe even higher frequency. And so there are companies that have put up large infrastructures. Planet Labs, for instance, basically takes a picture of the Earth every day at, I think, 50 centimeter resolution per pixel. This imagery, it has high refresh rates, high resolution, and is multispectral. Now, multispectral is very interesting because it turns out that treated water versus untreated water has a particular, kind of spectral signature. So if you're looking for water, okay, that's fine, but you're really looking for treated water, and you can identify that with the right algorithm from multispectral satellite images. So you're searching this multispectral satellite imagery, and then leaks can be detected that way. And I think some of these solutions are starting to be deployed by forward-thinking utility companies to complement and sometimes substitute for their traditional leak detection methods. And really what it boils down to is uploading and creating a data pipeline that produces that purchases really probably high resolution multispectral images, and that are of particular regions, and that are processed in the cloud with an algorithm. And that's the figure on the right there is an actual real image of some synthetic aperture, which gets rid of clouds, showing areas with potential water leaks. Another example, kind of similar, but a little bit different, and for a reason I'll explain, is finding natural gas leaks on natural gas pipelines automatically using satellite images. Conceptually, it's pretty much the same thing. It works in the same way as a water leak detection. However, it requires information that are relatively simple. It's more information than a relatively simple spectral signature. It requires basically different sensors. Essentially the proof of concept of this work was really published by NASA in a geophysics letters paper, and then a number of companies jumped on that and started to try to commercialize this stuff. And only recently has it been scaled out because specialized satellites that are needed for this purpose. And the reason the specialized satellites are up there now is because people are launching these special satellites because there's a global strategic need, to measure and monitor methane and carbon dioxide to address climate change. So it's because of that enablement that you can now use these things for this kind of commercial purpose. The competition for this kind of thing is obviously manual inspection, but also flying, planes over the area, and that gets expensive pretty quick using drones. Another example for transmission and distribution is vegetation monitoring. Vegetation management in utility companies, especially electrical ones, is a serious issue, and it's a costly and classic problem for utilities. Again, this is the kind of thing that it actually caused very large, multi-billion-dollar, well, bankrupting really Pacific Gas and Electric wildfires, right? It's very easy. There's vegetation encroachment on the infrastructure, spark flies, fire starts, and in some remote place. And imagine what it takes to manually inspect all of those transmission lines all over the state of California. It's difficult and expensive, and when it's not done correctly, it leads to some serious consequences. But a lot of new technologies, using LiDAR and drone and satellite imageries, have been deployed to effectively improve this process. AI and machine learning technologies such as object recognition and various computer vision approaches that are the same kinds of, some of them are the same kinds of computer vision approaches that work in your Google Photos or whatever, have been starting to be deployed here to at least try to help this problem. It's quite a difficult problem. Yeah. Finally, another one, also employing new kinds of data, is wildfire risk models. I recently went to a conference in Sacramento where this was obviously a huge topic, and public utilities like the San Diego Electric Utility is really on the leading edge with this kind of stuff. They have control rooms where they're essentially building, when they see a fire start and that's communicated by the fire department, they can run a real-time simulation that's at least reasonably effective, that's giving you a scenario about where that fire could go and in what time frame. And they cooperate closely with the fire department in order to act on those real-time simulations once a fire has started, and who should they evacuate, who should be prioritized, that sort of thing. It's really kind of a very sophisticated and impressive thing that San Diego's doing, and it was really cool to see that. And these kinds of simulations, are actually pretty straightforward, but they require. I mean, I think this is a good example where you're really taking a beautiful kind of technology, but really, connecting it to the operation of the company that's the companies that are impacted, and obviously it's a great benefit for the public at large. So that kind of winds up the discussion of some of the solutions that I thought would be interesting to highlight as they apply to using data and machine learning for utility companies. We've described lots of examples. Once the business objective is identified, assembling the data is often the first and hardest step. I was alluding to that really with the water company work that we're doing. It applies everywhere. I mean, most of AI and machine learning projects, 80% of the work is really working with the data. It's really only 20% of the work that's, actually building models and things like that. We found that organizing and rationalizing data with machine learning applications in mind, it leads to good, flexible, scalable designs. Because when you do machine learning projects, which I'll talk about in the next slide, you don't really necessarily always know what you're looking for and what you want, and so you need to have flexible and scalable designs. And if you do that, it's a force multiplier for the value of the data, and it's a good foundation on which to develop new applications down the road. So it's an investment really, but it's an investment that's very likely to pay off. Assembling the skills can be a challenge. There's a lot of demand for those kinds of skills, but machine learning algorithms and platforms themselves, especially from companies like AWS, Google, and so on, they really are a powerful democratizing force, along with elastic cloud compute resources. So it's not entirely necessary that you're, building a world-class machine learning data science team if you're working with partners who have experience and a good understanding, of best practices and so on. Because the actual algorithmic stuff that you need really is becoming commoditized. But it's really about how to put all the pieces together to drive business value, in my view, and having lots of experience and knowing what the pitfalls are in the modeling processes. Because you can't just apply commoditized processes blindly. You have to frame the problem correctly. You have to decide which algorithms are good. This algorithm is likely to work. That algorithm is not. That's really what the kind of work, what the kind of work is about. Um, one thing I wanted to talk about is that data science and machine learning projects are different from traditional IT projects in a basic way. They often involve uncertainty and fundamental technical risk. What I mean by that is really, if I'm going to move, let's say, an on-premise database to AWS, it's not that we believe that there's, fundamental technical risk that it can't be done. It can't be done. It can be done. There's always risks that are more business risks, but um, you don't doubt that that the job can actually be done. Whereas in machine learning, where if we're trying to say, well, can I predict pollution events with such so and so accuracy up to a week ahead of time? Sometimes you just don't know if that's possible with the data. And so you really have to internalize that kind of uncertainty and risk and make it part of the business argument that's being made. It may not work, but you're taking calculated risks. And you need sharp focus on business value and metrics. And it's not necessarily kind of the traditional machine learning metrics. It's really business-driven metrics. So really, therefore, kind of getting started is about three things. It's about finding relatively low risk, high value projects that have clear, measurable business benefit, building confidence in the organization and developing a culture, even if in sort of a pocket of success within the company. Choosing problems for which just the version 0 is valuable, but choosing that one that also opens up that has option value. It opens up, like, if V0 is successful in that thing, we have real business value, and then it's gonna open up a lot of options to many more high value iterations. So just sort of thinking about it from that perspective, I think, is something we found useful. I'll go quickly through some other kinds of projects, the real projects that we've done, so that you can just kind of get a sense of the breadth. I talked extensively about this, developed a pollution event prediction algorithm, providing real-time risk assessment and interpretable models to allow the possibility of risk mitigation. We've developed a computer vision AI algorithm that uses satellite images to automatically detect new construction in certain suburban areas, and it's used by companies that as a lead generation tool. So they want to know the instant new construction starts, and then they can go out and actually sell to them. We've developed a deep learning based algorithm on satellite images to predict corn and soy crop yields in the US and South America that is as good as better than the periodic USDA forecasts. It's something that happens in real time. And the USDA forecasts typically come out on the first of the month in the last 4 months of the year, and these are market moving things. And intermediate or earlier in the year, investors and producers may not have information that's current, but these satellite images and these algorithms, they just run every day. In fact, there was a time when the USDA's, because of funding, their forecasts, their highly relied upon forecasts, the WASDE numbers, were suspended. But if you're using a satellite signal, it's okay. Because it was suspended because of a government funding situation. We developed a text-to-speech solution for customer support calls to a large healthcare provider, a number of novel recommendation systems for a food delivery startup and for a clothing wholesaler. Those are interesting things that really enhance the user experience. We've deployed a cloud machine learning service, AI as a service on AWS, with custom-built algorithm to optimize lead generation that increased our customers' gross revenue by 25% in 9 months. It made a big difference to their business. We've deployed, and this is some of how we know how difficult it is to deploy AI in our own businesses, deployed it with our own cloud operations center to dramatically reduce the time and labor costs of classifying and triaging the flood of events that come from application monitoring. It's very similar in a way to the predictive maintenance thing. It's allowing us to be predictive instead of reactive. We've developed an AI algorithm for an R&D organization that performs extensive experiments every day using live animal subjects. Because there's a long historical history of that, and because we've worked a lot with that data, our algorithm could predict the outcome of these experiments with 75% accuracy. So it reduces even the need to do many experiments that, the algorithm is very, very certain will fail or be uninformative. So at this point, I think we're ready for some Q&A, if there are any questions.
Yeah, so any of you that have questions, there is a question box, in the webinar dashboard. So if you just kind of click there and type in your question, and then we can kind of get it over to Rajan. But as you were speaking, there was some of you guys have submitted some. And the first question, Rajan, is what does it take to qualify for a funded POC?
Well, I may not be the best person to answer that, but I think we'd really be looking for a well-defined kind of through conversation arriving at a well-defined problem that we felt could be probably solved within or addressed within. It has to be scoped correctly, really, and something that would hope to have business value. I think that's something that maybe we can. If you're interested in doing that, you should just definitely get in touch with us and with Zach, and we can certainly answer that question in more detail and more specific to the problem that you might have in mind. That would really drive it, I think.
All right, then have there been any AI models created to predict the demand of electric cars on the grid as electric cars get more in the market?
I believe we have not done that, but I believe I have seen work on that. Yes, there's been electricity demand prediction is sort of a thing, and there has been a lot of work done on that. I'm just trying to recall if it's specific to electric cars or not, but certainly that kind of the same kinds of approaches that are used for different kinds of electricity demand in general would could be adapted to that, I would think. So I would say my guess is the answer is yes.
Okay.
I could bring up more references.
Is there an AWS service for documenting OCR scans?
For by document, okay, so there is an OCR AWS service. We worked with it, in fact. And yeah, so I think the answer to that question is yes.
Okay.
We've had some experience with it, so you should get in touch with us with our experience because we've tried them out from multiple different services. Google has one and all that, and there's some crowdsourcing types of things that are hybrid machine learning and using crowd annotations to extract information from documents. So that's something we've done some work in. So we'd be happy to share our experiences with that because there are lots of trade-offs and pros and cons.
All right. So what tools are available in the market to support AI and machine learning models?
Zillions. Yeah, zillions. I mean, all of the big players are trying to produce their own kinds of software and services. Typically, they're trying to go the service route. They want to be AI's, at least AI algorithms as a service and AI infrastructure as a service. So there's those kinds of players. There's kind of the more sort of, there's companies like big. I mean, there's so many consulting companies. There's a lot of tools out there, and many of them open source. We primarily actually work with open source tools. I prefer to work that way. They're very, very powerful. And if you just have the expertise and experience with it, you can get a lot done with just those tools. But the answer is, yeah, the real answer. I mean, I'm sure we have some resources on what that landscape is. Maybe we could share them with you if you get in touch with us. Yeah.
Okay. And then, what kind of skill sets are needed to be an AI machine learning modeler?
That's a good question. You need to know how to program. Personally, I think that there's of course specialized AI, machine learning, courses that teach you the stack. But I think honestly, sometimes when I hire, if a person doesn't even have that kind of training, but the person has a good training in some other quantitative discipline like statistics or engineering or operations research or whatever, or physics, maybe where they've really learned how to think about data and how to think about the basics of statistics, Because at the end of the day, AI and machine learning is really about statistics. It's about hypothesis testing, framing, those kinds of things, and being comfortable coding, of course. And then I think the third thing is curiosity. I think you have to have really genuine curiosity that, if someone tells you, um, you know, I mean, an example. Yeah, well, there's lots of examples, but I think, curiosity, a quantitative mindset, an enjoyment of coding, and some really sound statistical training, I think are the key. The rest can be learned. Yeah.
Okay. And does the San Diego Electric Utility, as you had in your example, do they own their own satellites or do they lease subscribe to a service?
They no, they do not own their own satellites. They buy their data, I believe. They buy the images that they need. And that's
Okay.
almost becoming a commodity. You can almost click, click, click and buy some high resolution satellite images these days with a credit card.
And how much and how old does data that is needed to develop these models?
Yeah, it depends on the question. Always, as a general matter, the more historical data, the better. In the example I gave with the doing the laboratory experiments and building a machine learning AI model, and we had 10 years of data for that. Because they've been doing experiments for 10 years, and that's fantastic. For like crop yield forecasting, you want that data going back as far as you can. It really kind of depends on the application. If you're just doing change detection, then you only need, for new construction, you really need satellite images in two different time slots. That's it. But as a general matter, for predictive maintenance and things like that, you want all the data, because that's the only way. The only way you're going to look into the future is if you have a lot of information about the past.
Okay, and then so what are the steps if you're very new to this? I mean, what are the initial steps that you have to do to even make your data usable? To get to these, AI machining models,
Yeah.
machine learning models.
Yeah, I mean, I would say honestly, that's a question for conversation, and it's a little bit bespoke. It happens kind of in every different circumstance, but I always believe that doing AI machine learning projects really, it's always about the data. You can't do anything without the data, but you also need to ask the right question. So it's almost like, what is the thing that I really want to know? What is the question I really want to answer? What is the probability I really want to estimate? And what is the thing that would have high value? And once you identify that, you kind of work backwards to, okay, so what do I think influences that? Where is that data? What does it look like? How can we put it together? All those kinds of questions, I think, are the way to start. It's almost you can't. I think it's not necessarily a great thing, although it can still work, to just say, okay, I want to take my data and put it in, so that anybody can do machine learning on it. I don't think that that's going to drive you quickly to something of value unless you know those one or two V0 low-hanging questions that should really begin to drive the way that you organize your data. And we're
And
happy to
then,
have those kinds of conversation.
can AI and machine learning models be run against traditional enterprise data warehouses?
Yes.
Okay, and I think there's one more. Are there any use cases for AI machine learning for customer service call centers for utilities?
Yeah, I mean, I don't think it would be really any different. I mean, if it works for healthcare, it seems to me it should work for utility companies. But it's very similar to, yeah, call center technology. I mean, that's kind of one of the reasons I wanted to go through that, because it's not specific. It's not an example that's specific to the utility company, but that's a horizontal function that almost every company that has consumers faces, and there are patterns and tools for that. Yes.
Okay. Well, does anybody have any additional questions? Feel free to throw them in there in the in that question portal. We'll go to the finishing up slide, Rajan.
Okay.
Going into then going into these next steps for the AI journey.
Yeah, this is more just a quick review, right? Optimize. The idea is to, yeah, I mean, it's you're driving automation, and with the data, you want to create a virtuous cycle where you're enriching the data with new kinds of data. That's a little bit of like the second category of things I was talking about. And then really then you're opening up the possibility in your journey for new products and new things that you really innovation really. And it's about creating that kind of feedback loop where you're getting data, you're getting results, and it's making your data better, and you're understanding your business better and looking at opportunities, and you're advancing your data strategy, and eventually, creating perhaps an organization and a mindset within your organization to exploit what you've learned. So we'll make the webinar available to participants, and we're very open to having conversations and discussions about how to get started and about the business needs and problems that we may be able to address with these ML and AI solutions, and talk about the data questions that are always attended to that. Yeah, and some organizations might qualify for these POCs, and we're happy to have those discussions. And you can, for many of those kinds of things, please get in touch with Zach. And I guess we've got this is just a list of some upcoming webinars that might be of interest that are related to this, primarily around data and building data lakes and warehouses and Redshift and so on. Okay.
All right, Rajan. Well, thank you, and to everyone that joined, thank you very much, and I hope you guys have a great afternoon.
Thank you.